So looking at this situation, we have Bonnie. She's launching a model rocket from the ground. The initial velocity is 68 meters per second, and we have the function right here that's used to describe the height in relationship to the time. So obviously this rocket is going to go up for a while, it's going to stop, and then it's going to come back down to the ground. Sasha, her friend, is at a lookout point, probably in a building someplace, 72 meters above the ground. So looking at this, question A, what's the value of h of t? And that's not h times t, it's function notation. What's the value of h of t when the rocket's at Sasha's eye level? Well, that's just a dead giveaway from the question. Sasha's eye level is 72 meters above the ground. So the rocket would be at 72 meters. So now question B, substituting the value of h of t into that equation, well, 72 is h of t, so really that would become 72 equals negative 4.9, it's supposed to be negative 4.9 t squared plus 68t. Part C, to graph this function, we actually need to have a 0 on one side of the equation. The graphing calculator is only capable of accepting an equation if there's a 0 on one side. So what we need to do to that equation in B is we need to take and we need to subtract 72 from each side, which gives us 0 equals negative 4t squared plus 68t minus 72. At this point, we can turn our attention to the calculator. Turn it on. If you want to do a reset, it's second plus 712. And we need to enter the equation. So we'll go to y equals. Now, we're not going to enter the 0. That's for the y. We're going to enter everything on the other side of the equals sign. The only problem is the calculator will only let us use x's, whereas we have t's. It's not a big deal. We just need to remember that every t is also actually an x. So we'll put in negative 4.9 x squared plus 68t, or 68x, minus 72, and we'll graph it out. Now, this is going to make the shape of a parabola, but from what we have here, it doesn't look like it. So what we need to do is we actually need to change the zoom. The best way to start with this is to do a zoom fit. So we go to zoom. Zoom fit is option 0. Hit enter. The calculator thinks for a minute, tries to find the best window settings possible for us. It's not perfect. Okay, we have a lot of real estate below the x-axis that we don't need, and we're trying to use the zeros function to find the x-intercepts of this graph. So now we can go into the window settings. Y-min at negative 1200, we probably don't need that much. I'm going to change it to negative 100. The Y-max looked okay because we could see just the top of that parabola. The X-min is okay, but the X-max I'm going to go to maybe 20, just because we need to see that second X-intercept. And again, this is a guess right now. Hopefully I have a good guess. I may have to go back and adjust my window settings after I graph. Or I may have got lucky and I have good window settings. So now to find the zeros, we have two things we have to find. This one on the left and this one on the right. It'll be the same process each time. We're going to go to second trace. We want option 2. And the calculator is going to ask us a couple of questions. Left bound means we have to move to the left of the point. Well, right now it's up near the top, which is not to the left of our left point. So I'm just going to scroll back until I get just to the left of that point. And I'll hit enter. The right bound, now I have to be to the right of that point. So I'll scroll a couple of times until I'm to the right of it. I'll hit enter. Wants me to guess. It wants me to get close. So I'll move back. That's probably as close as I could get. Hit enter again. Allow the calculator to calculate. So we have t equals 1.15. Since it's time, that would be 1.15 seconds. And now we just repeat the process for the other one. So second trace, option 2. Now my left bound shouldn't be there. My left bound should be right about there. I just need to be to the left of that point. So I'll confirm that. Right bound, move to the right of that point. My guess, I'll move close, and we get a second point at t equals 12.72 seconds.